Start recording. What I want to talk about today is kind of the loose bits before midterm 3. I know that last week we covered a lot of expected utility and insurance, so that's going to be a major topic for the midterm. The next large topic that I want to talk about is demand, right? So demand. Typically, and this should maybe have already been covered a little bit in your past micro classes, but I'm hoping that this can serve as a refresher. So demand, right, is something that we've already kind of encountered earlier in the class with the different kinds of consumers and the different kinds of goods, right? So we have it that normal goods, demand will increase for normal goods when our income increases. Ordinary goods are when the price decreases, demand will increase, right? So we've already had some sort of encounter. Now we're just going to kind of formalize it a little bit more, okay? And we're going to be talking about this kind of concept of market demand, which market demand maybe sounds like it's a bit overwhelming, but it's basically just the sum of individual demand, right? And you'll probably see it expressed in a more maybe mathematical context, right? Where it's just going to be the sum, right, from I equals 1 to n, right? Where n is the number of consumers in the market of individual demand. So we'll call demand I, and this will be just a function of the price, right? So in this case, we're going to say that consumers are going to make their optimal choices on how much to consume based on the price that's given in the market, right? So we know that market or that prices are kind of just given, right? And that depending on what the prices will be, that's going to affect how much demand is going to be occurring in these markets. So let's take a look at an example of something that you may have to come across on your midterms, right? So, and that's going to be just the idea of adding up these demand functions when they're on a graph. So let's take a look at a two consumer market, right? So we have consumer 1, where they're going to have this kind of demand curve where we have P and Q on our axes, right? So quantity and price. And we're going to have it that, right, when the price is higher, we're going to demand less. And when the price is lower, we're going to demand more. So this should intuitively be downward sloping, okay? So here is our 6, 4, 2, 1, 2, 3, right? This is our demand function for consumer 1. This is his demand as a function of price. And so I know that typically you are used to seeing the x-axis, right, as being the independent variable, right? Where basically x was kind of impacting y, so y was a function of x. So you're used to kind of having this relationship where this axis is what's affecting this axis. But I just want to remind you guys that demand for any individual I is a function of P, meaning that price is what's going to affect this axis right over here, okay? So here is consumer 2, and they're going to have this axis, right? So 4, this is quantity, and this is price, and 4, 6, 8, and 2, right? 1, 2, 3. And this is what their demand function is going to look like, okay? And so we want to think, what is a combination of these two individual demand function that we can use to create a market demand, right? So I'm going to maybe squeeze this a little bit, but this is what it's going to look like. right? We know that our prices are still going to stay the same. We're going to still have 2, 4, and 8 be our prices, right? Because nothing is going to really change what this axis is. But when we're combining quantities, right, that's what's going to affect this axis right over here. So how I like to approach these questions is think about the demand at each individual price level, right? And then create a composite graph that kind of captures that. So we look at what the price is, right? The maximum price in each market is $8. And we know that when the price is 8, there's going to be 0 demand from each consumer, okay? So price of 8 is going to have 0 demand, so quantity will be 0. Now let's take a look at what happens when the price drops down to, say, 6, right? When the price drops down to 6, we have that consumer 1 is going to be consuming, right, 1 unit of quantity. We don't know what the quantity is, but we're going to have it that 1 unit is going to be consumed in the entire market, right? So consumer 2 isn't consuming anything. Consumer 1 is using 1. Here, let me just mute that quick. All right, cool. Here, yeah. Okay, so we have it at this price level. We're gonna have 1 unit of consumption. So let's go to a new price of 4. So the price of 4 has it that consumer 1 is consuming 2 units of consumption, but that consumer 2 isn't consuming anything just quite yet. So at a price of 4, we're still going to have 2 units being consumed within the market. Okay, now let's drop down to price level 2. Okay, consumer 1 is going to be consuming 3 units right over here. But when the price of 2, right, when the price is 2, I should say, consumer 2 is now going to enter the market. So we're going to have a combination, right, of 3 units being consumed by consumer 1 and 2 units being consumed by consumer 2, right? So there should be 5 units total. 1, 2, so 3, 4, 5, right? And let's kind of just look at the last price level when the price is 0, right? And notice how I went in intervals of 2. You could be more precise and go 8, 7, 6, 5, 4, 3, 2, 1, right? But because it's kind of linear, I decided to just keep it this way. But it'll kind of vary by the problem. So we have our last price level. When the price is 0, consumer 1 is going to consume 4 units, and consumer 2 is also going to consume 4 units, right? So I'm squeezing it a little, but 6, 7, so 6, 7, and this is 8 right here. This will be the last point. And so notice how our graph right here is linear, right? It's kind of linear, but it's broken up, right? And that's because consumer 2 doesn't play a role in this market demand curve until a certain price level, okay? And so that's what we're going to consider, right, when we talk about the difference between intensive and extensive. So when we talk about the definition of intensive, we kind of refer to consumers that are already consuming will consume more with lower prices, right? So an example of someone who was intensive was consumer 1, right? So consumer 1 was consuming at a price level of 6, and they're going to consume more at a price level of 4, right? So that's what they mean by intensive. You can kind of think of intensive as in the game already, or something in that way, involved, right? They were already involved at that point. And so consumer 2 in this case will be extensive, right? Where extensive is someone who isn't consuming at a certain price point, but if the prices are low enough, they'll start consuming a positive amount, right? So in this case, consumer 2 is extensive at a price level of 4, right? So when the price is 4, they don't consume anything, but anything past 4, in terms of prices, so anything lower than 4, then they're going to start consuming. So those are kind of the two definitions. I'm not sure if it's worth writing down, but it can kind of explain why it is that our demand function has like this kink, or I guess our graph for the demand function has this kink, right? And that's kind of why. So I think that it's a really useful skill to be able to draw these. You probably won't be asked to draw these on your midterm because it's multiple choice, but it is very fair game to be asked which market demand um, best summarizes the individual demands. So in a way, you will have to be asked to draw, right? Um, but that's kind of how you would go about it. Are there any questions about that? Uh, would you do this the same way if you're given two? Okay, yeah. So it doesn't really. So yeah, that's a really good question. These two people technically do have different demand functions, right? Consumer one has a demand function that looks something like this, where I don't know. I guess if you were to draw it, it would be something as a function of price. So let's say 0 plus I don't know, 1/2 p over 2. Actually, I don't even know what the demand function would be here. I guess I could obviously come up with one. Um, or I guess 4 minus p over 2. This would probably be the demand function for consumer one, right? It's a function of price. So when the price is 8, you're consuming 0. Price is 6, you're consuming 1 down to price of 0. But you notice how these people have different demand functions, right? This person is just 4 minus p as their demand function. Um, so kind of to come around back to the question that you were asking, yeah, you're pretty much always going to have different demand functions in terms of like each individual. And so it'll be coming up with a common graph that best matches what each individual shows. And I know that sometimes you're asked to combine the individual demand functions. Um, I'm not sure if there's like necessarily best practice for doing so. I kind of do it a very primitive way where I do a lot of just plugging and chugging and seeing if that works. And I unfortunately don't have an example in front of me that I could maybe try. So maybe if you were to come up with one during my drop-in, I could definitely answer that. But um, I don't think there's a best practice for how to come up with an algebraic combination of these. Um, Typically, what I would do is I would just analyze the graph and come up with the multiple choice answer that best fits what the numbers reveal. Okay. And actually, now that you mentioned that, I will try to come up with one for tomorrow's drop in. So if you guys want to come to that, I know that that's something that actually does provide quite a few challenges. So um, yeah, you guys are more than welcome. So typically they don't like to do that. So typically you'll just be given one function that's asked to kind of map the market demand that's already given. And so when you do that, typically they might already have a graph for you. But if they don't have a graph for you, that's when you would draw the market demand graph that I just drew. And then you would kind of map it to see whether the numbers match up, right? And the way that you would do that is typically just by plugging in the various prices and seeing whether the quantity that the algebraic function puts out matches what your graph puts out. So let's say that I have um, a market demand, right? P and Q, and it looks something like this, right? This is pretty arbitrary, but the way that I would do it, right? And so typically they'll have di of p equal to some function of p, right? So this could be like 5 plus p over 6, all that divided by 13, for example, right? And this is arbitrary as well. the way that I would see whether this specific algebraic function matches up with the demand function that I've drawn is I would plug in the various prices, right? And see whether, right? So this is just quantity. See whether the quantity that gets spit out here is a quantity that matches what I've drawn, which should be very accurate. Okay. So I think that's probably best practice. I know that it doesn't sound like a very like nifty shortcut, um, but I think most of the time you will get the right answer as long as you approach it pretty carefully. And it's all contingent on drawing the market demand correctly. Okay, I'll say that. So hopefully everybody understood that. I think that it's okay if you're a little bit confused because I think in this particular part of the class, that's like the aspect of this content that gets mixed up the most. But yeah, no, that's a great question. So I want to move on and talk about price elasticity. So price elasticity, you've probably been introduced in your previous micro classes, right? So this part of the class should be a review of your micro classes. But we've typically thought of elasticity as being equal to just the percent change in quantity divided by the percent change in price, right? And so this is like a good preliminary way to think about elasticity. But we're going to be moving on to a more, I don't want to call it nuanced, but it's um, a more mathematically intensive, I guess, way of approaching elasticity. So the new way that we're going to be talking about elasticity in this class, and so you'll see like the subscript right down here. This pretty much just means that we're going to be taking the elasticity of good one with respect to price one, right? So this is how you can read out what the subscript means. Elasticity of good two with respect to income, right? These are all possible variations of elasticity, right? And pretty much what it's saying is if I have a demand function, x1, that is a function of p1, then I'm going to be taking this demand function as a like in terms of p1, basically finding the elasticity of this demand function in terms of p1. Okay, and it'll make more sense when we kind of start talking more and more about demand functions and why they're important with regard to elasticity. But to kind of formalize our equation, right? So let's just erase this. To formalize our equation, this will be the partial derivative of x1 with respect to p1, right? Times p1 over x1 star, right? And so x1 star, you'll notice is just the demand function that we start off with. So let's actually bring these back. So if I have something that looks like this, the elasticity of x2 with respect to income, then this would be the partial derivative of x2, the demand function, with respect to income times income over x2 star. And so hopefully you guys are sort of noticing a pattern here in how you can come up with these equations, right? There's always going to be this cross interaction, right? Where you'll have the derivative of the demand function that you're looking for, and this will be the demand function for that good, right? And this will be what you're taking it with respect to, and that's what the numerator of the second term is going to be, right? So hopefully this is kind of making sense and you'll be able to write it out. But what does this all mean, right? So why is the idea of elasticity something that's important? Well, elasticity is important, and I'm going to kind of draw this curve for you guys, just so that you guys kind of get some context behind why we do this, right? But elasticity is important for a few different reasons. So let's just take a look at a specific, or not a specific, just a general demand curve, right? So P and Q on our axes, right? And something that looks like this, right? Where we're downward sloping, okay? And we're gonna use D of P, right? We're just going to kind of generalize it and say that this is equal to A minus BP, right? Where this is some constant, and this is just another constant, right? So this is about as general as it can get. So we have it that elasticity, right, based on this function right here, is going to be equal to d prime of P, right, times P over d of P, right? And so hopefully you guys are kind of seeing how this relates to, say, right? Right, hopefully you guys are kind of seeing how this equation mirrors this equation right here, right? Where this is just the derivative with the function with respect to price, and that this is just the price over the demand function, okay? So hopefully that connection is being made to you guys, right? So we consider something to be elastic if the absolute value of the elasticity is greater than 1, right? So typically, elasticity will be a negative value just because of the fact that it's downward sloping, right? So if you take a look, this derivative will typically be negative, right? Whereas this fraction right here will be positive because demand is positive and price is positive, right? So that's why we take a look at the absolute value, okay? And we're going to say this inelastic is when the absolute value of elasticity is less than 1, unit elastic, which doesn't appear so often, but that's pretty much just when the absolute value of elasticity is equal to 0, right? So we have our graph right here, and we're going to say that this portion, so let's split this up into 2 halves. So this is Q over 2. This is just the midway points of our demand curve, right? We're going to say that anything on this end right here is going to be inelastic, right? So, or whoops, this is actually, my bad. This should be 1. I stand corrected. But we're going to say that this portion of the graph is what we call inelastic, right? And we're going to say that this portion of the graph is what we call elastic, right? Meaning that the absolute value of elasticity is less than 1 here, and it's greater than 1 here, okay? And so why do we care about elasticity? That really hasn't been quite answered yet. Well, I'll tell you guys why. So let's just make some space right here. So we know that revenue, so this concept of revenue is basically just the amount of money that we make. So that's how much we sell times how much we sell it for, right? And so we know that there's going to be one single price in the market because prices are just given. So we know that the revenue is going to be equal to demand times the price, okay? So when we take the derivative of revenue with respect to price, right, we're going to, by the chain rule, we're going to get d prime of P, so d prime of P, plus times P plus d of P, right? And so what this equals to, right, if you were to simplify it out, this is equal to d of P times 1 plus d prime of P, right, times P over d of P, okay? And this is just some equation that should be given to you guys in lecture, right? But the idea is that this is equal to d of P times 1 plus elasticity, right? Because this whole term right here, if you look at it, is equal to the elasticity equation that we were given beforehand, okay? And so if we look at this and we think about, well, my revenue is a function of the demand and elasticity, right? Which means that if something is inelastic, right, then when we kind of look at what is going on, right, if something is inelastic, then this value is going to be less than -1, okay? And we're not looking at absolute value anymore. We're just looking at it in terms of what it actually is. So if something's inelastic, then this is going to be between 0 and -1. And if something is elastic, right, then this is going to be something that is less than -1, okay? And so if we think about, right, how this plays a role in revenue, we know that when we're taking the derivative of revenue with respect to price, we want to see how our revenue how our revenue changes as we increase our price, right? So if we know that elasticity is some value that's less than -1, then when we increase our price, then our revenue is actually going to go down, okay? And so you guys can maybe see that if you substitute values of elasticity into here, right? Basically, what I'm trying to say is that if something is inelastic, then our revenue is going to go up as we increase our price. But if something is elastic, then our revenue is going to go down as we increase our price, right? And so there's a general rule. So if something is inelastic, then the derivative of revenue with respect to price is going to be greater than 0. And if something is elastic, right, then derivative of revenue with respect to price is going to be less than 0. And so maybe I can kind of show you guys on a graph how we can show, like, prove this, right? So let's say that prices are currently right here, okay? So prices are right here and quantity is right here, okay? So the revenue that we're currently making is going to be this rectangle right over here, okay? And notice how we're in the inelastic portion of our graph. So we want to say, well, let's increase our prices, okay? We increase the prices and we now set prices here, right? So this is our new price. And because quantity, right, because demand is a function of price, when our price increases, our quantity demanded is going to go down, right? Hopefully that should make sense. And so we're going to have a new quantity, optimal quantity, that is going to be right here. So we think about how much our revenue changes. Well, we're going to lose this revenue that we had before, right? You notice that this area right here, and I wish I had a different color to kind of show this, but this area right here is lost, but this area right here is gained, okay? And so mathematically speaking, right, we know that this area that is gained is going to be greater than this area that's lost, which means that there's going to be a net positive value to increasing your price. However, if we're on the elastic portion of the graph, then this area that's gained is going to be less than the area that's lost, meaning that we're going to have a net negative effect of increasing our price. Do you guys kind of see, like, how that is kind of shown here? Are there any questions about that? All right. I'm going to take it that because there's no questions, people have a pretty generally good idea of what I mean. And so if you don't remember the graph, which is fine, I just want you guys to remember this, right? Which is pretty much the product, right? This is the product of all the work that we've shown right here, okay? So that's kind of what it means. Before I move on, I want to ask if there's any questions just about anything that I've captured so far, because next we're going to go on to taxes. Right? All right, sounds good. So let's get into taxes. And this is where I really wish I had, whoops. This is where I really wish I had more markers. I left them all in IV when I went home. So let's look at taxes. Okay, so the kind of cool thing that is mentioned in this class, and this is mainly why we cover taxes, is because of this thing called the incidence of tax, right? Where pretty much whoever we tax, it won't really matter because each side, so the consumer and the supplier, are both going to bear equal burden from the tax. So it's fine. I'm all right. So let's take a look, right, on a situation where we have a tax on sellers, right? And so let's just say that we have this graph right here where P and Q are our axes, and we have a demand function right here, and we have a supply curve right here, right? So currently, the equilibrium price and quantity are going to be where the supply curve and the demand curve meet, okay? So let's just say that we have a tax on the sellers right here. A tax on the sellers means that the supply curve is going to have to shift upwards, okay? Pretty much the reason why is because for each unit that they sell, right, they're going to have to pay some portion of that to the government. And so in order to come away with the same amount of revenue, right, they're going to have to increase their prices as a result. So a tax on the sellers is going to cause the supply curve to shift upwards by the amounts of the tax, right? So this difference is going to be the amount of the tax, right? And so if we look at consumer surplus and producer surplus before, and so I'm going to go on the assumption that you guys have a pretty good idea of just generally what producer surplus and what consumer surplus is, right? We know that consumer surplus is going to be this triangular area, and producer surplus is this triangular area. So we look at this tax on sellers, right? The consumers are going to have to pay this price, right? This is the price that they pay at the register. And we know that the producers, after they pay the taxes to the government, right, are going to come away with this much money, right? So for each unit that they sell, they receive this amount from the consumer, but then they have to pay this tax difference, right? And so this is like their net profit, if you will, right? Just from selling the good. Okay, so if we look at what this means for consumer surplus, right? You guys can obviously see that this triangle right here is smaller than the triangle that we had beforehand, right? Meaning that our consumer surplus, if we just want to track it, went down. And you'll also notice that because the net profit from the producers is now lower, right? That this triangular area right here is less than the triangular area that was existent beforehand, right? And so we have it that producer surplus also goes down. So you might be wondering, well, if both of these goes down, what could be the benefit? Well, the benefit right here is this rectangle, right? That we're going to call government revenue. So this is basically tax revenue. And this is the amount of the tax times the new number of units that are sold, right? So tax revenue, we're going to say goes up, right? And this is going to be T times Q prime. So we're going to describe this amount of quantity being sold as Q prime, right? And we can say that this original was Q star, right? Yada, 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 okay? And this doesn't really look like a prime, right? So this is T times Q prime. So you'll notice that there's some area of this triangle that was existent before that hasn't been quite covered yet. And this is going to be this little section in black, right? That we're going to call deadweight loss, right? So this is what we call deadweight loss. And deadweight loss is essentially just the loss in surplus. It doesn't really matter who it was, right? Or who owned the surplus. This is the loss in surplus from moving away from the optimal equilibrium, right? So we know that the equilibrium was here before, but we've moved away from this equilibrium, right? And we now have a deadweight loss because the government's not getting this surplus, and neither the producers or the consumers are getting the surplus, which means that this is essentially just loss from the market and can't be recouped by anyone, right? So we know that deadweight loss can only occur, right, when there's a change in quantity, or else there would just be no area, right? So we can think of deadweight loss as occurring when quantity changes from the optimal amount that was existent before, okay? Um, so this should all be kind of reviewed to you guys. The reason that it's brought up in this class is because if we were to look at the same effect, right, of the graph, this would be equivalent to if we had a tax on buyers, right? You'll notice that this same exact loss in surplus, um, if drawn to scale, is the exact same. So let's kind of just see what I mean by that. So P and Q right here, supply curve and demand curve, right? So this is Q star, this is P star, right? So this is our starting consumer surplus. This is our starting producer surplus. There's no tax revenue and there's no deadweight loss yet, okay? So let's say that the tax is on the buyers. Well, that's going to force the demand curve to shift down, right? So we're going to have something that looks like this, right? Just like that, okay? Now, you'll notice that the price at the store that's given to the company is going to be this amount, right? So this is how much the consumers are going to pay at the register, right? Which means obviously producer surplus is going to go down. However, the price that they pay at the store is not the full price that the consumers are paying, right? Because they need to pay the amount of the tax, which is right here, right? So after they go to the store, they need to pay some percentage of how much they bought to the government, right? Which means that they end up paying a higher amount than what they paid at the store, right? So you'll notice that we have this same change, right? This change in producer surplus and consumer surplus is the exact same change as the surplus in this question right here, right? You'll notice that the tax revenue is the exact same as long as tax is the same, right? And then we still have this deadweight loss that's right here, okay? So basically, it's a very interesting phenomenon that occurs, is that no matter who you put the tax on, right, the effect on everybody is just going to be the exact same, okay? We'll have it that the surplus for the consumer and the producers goes down, tax revenue goes up by the same amount, and then we have the same deadweight loss, okay? So that's kind of the idea with taxes. I think I want to say something more general, which will help you kind of determine who gets taxed the most. So we're going to say that whoever is more inelastic will bear more of the tax burden, right? And so you can kind of understand why this is true, right? People who are inelastic, they don't change their quantity a lot with changes in price, which means that they're still going to consume roughly the same amount, even if they have to pay a tax, right? But because they're consuming a very similar amount and the price is higher, they're getting screwed more than someone who is more elastic, right? And you can kind of see this on maybe this is like the demand curve, this is a supply curve, right? This is very inelastic and this is very elastic, right? So any tax, right? So let's see, a tax on the sellers, right? Um, they're going to these people right here are going to suffer a lot more than someone who's elastic, okay? And that's just kind of a general statement about elasticity and the intersection of that with taxes. Um, but this is something that you guys can kind of just remember. I don't think it's necessary to um, prove, but this will be kind of important when you get questions about who is bearing more of the tax burden or something along the lines of that. Okay. So with that being said, I don't know if there's anything more from a content side that I really want to show you guys. Um, but there are some questions from the extra problem sets that I think would be good to cover. So if there's no further questions, we can move on to extra problem set 6 for the remaining five-ish minutes. And we can go over some of the questions that I think will be of use to you guys. All right. So are there any questions before I move on?
The consumer surplus is the top triangle, right?
Yeah, so consumer surplus is like the demand, like area that's underneath the demand curve, but over the price, right? So if I were to just kind of summarize it real quick, right? Here, this is consumer, this is consumer surplus, this is producer surplus, right? And if I get something like this, where there's a change in price, then this becomes the producer surplus. The consumer surplus is still there, but this becomes tax. And this becomes deadweight loss, okay? And you guys can kind of play around with the graph and see what happens when the graph looks different, but this is like the most general way of kind of showing it, all right? So hopefully you guys have extra problem 6 or extra problem set 6 already pulled up, because I'm just going to go over those real quick. And we will actually get an example of elasticity where we can actually do it very formulaically, okay? So I just want to remind you guys how to come up with demand functions. So actually, we're going to look at question number 3 first. So question 3 from extra problem set 6, we're given that the utility function is 12c to the 1/4 over or times f to the 1/3, right? This is a Cobb-Douglas equation. And so we're given the question, what is optimal demand for candy and fries? So there's going to be a different demand function, right? Depending on which good we're looking at. So the first thing we want to see is what kind of utility function we have. This is Cobb-Douglas. So let's take a look at our MRS. So our MRS is C x2 over d x1, right? The constant doesn't really matter. So C in this case is 1/4. So this is 1/4 F over 1/3. Let's see, this is x1 is C. Okay. And if I were to kind of simplify this out, this would be 3F over 4C, okay? I just multiplied everything through by 12 over 12, and I got this, okay? This clearly has DMRS, right? Which means that we can set this equal to our price ratio and find the demand function, right? So P1 over P2 is our general demand function or general price ratio. And so we get 3F P2 equals 4C P1. And let's solve for F first. So we get F is equal to 4C P1 over 3 P2. And we're going to plug this back into our budget constraint, right? So we have P1 times C. So P1C plus P2F. And now we have 4C1, 4C P1 over 3P2. So this will simplify out to 4C P1 over 3P2, right? And this P2 will cancel out. And so I have 4C P1 over 3 plus P1 over P1 times C is equal to M, right? And it just becomes a matter of solving for C. And we're going to have it in terms of P1 and M, okay? So if I were to group this, so this would be 7 P1C over 3, right? This is pretty much just 3 P1C over 3. And I add this to this, right? The same denominator, you just add the numerator, right? Is equal to M, right? And I want to find C. So I get that C is equal to 3M over 7P1. Okay? Now, I don't have that much more time, so I'm just going to leave it as the demand function for candy. You would do the exact same thing for fries, right? So what is her own price for fries? We're just going to substitute that in for candy. But basically the same exact steps would apply, except that instead of solving for F here, you would solve for C, and then that would give you French fries, okay? So that's kind of how we would go about doing these demand functions in case you guys forgot. But we're given question B, except that instead of French fries, we're going to use candy. So own price elasticity for candy, right? We have that the elasticity equation, right? So this will be for candy with P1. So P1 refers to candy right here. This is equal to the derivative of candy with respect to P1 times P1 over C, and I guess C star. And so if I take the derivative of candy with respect to P1, this is equal to 3M P1 negative 1 over 7. So C prime is equal to negative 3M over 7 P1 squared, right? So this is equal to negative 3M over 7 P1 squared times P1, and that's just P1. And all of this over the demand function, which is 3M over 7 P1, okay? And this is the own price elasticity. You'll notice that we're able to cancel some stuff out. So let's see how we want to do this. Well, we know that this can be simplified out to negative 3M over 7P1 squared times, if you just multiply P1 by the reciprocal, this is 7P1 squared over 3M, right? This 3M will cancel and this will 3M, right? And we get a lot of cancellations. And so we get that this is really just negative 1, okay? So if I want to interpret this, and I know that I'm going over on time, it means that a 1% increase in the price of good one will result in a negative 1% decrease in the quantity of seeds of candy. So basically, if you increase the price of candy by 1%, you're going to lose 1% demand. Okay. Um, and so I kind of went through that pretty quickly because I was short on time. But I think that generally speaking, this is a pretty quick extra problem set. So this will give you guys quite a bit of practice with this. So yeah, are there any questions about kind of the steps that I took here? Here? And as always, if you don't want to ask questions here, you can feel free to go to my office hours, or I guess my drop-in hours, and I can answer your questions there. But yeah, this is I think number 3 in this problem set is probably the best practice, because you get kind of a refresher on finding demand functions, and then you can work with those demand functions to find elasticity. So I guess with that being said, if there's no more questions, you guys are definitely free to go. Um, and just a reminder that we won't have anything on Wednesday because CLAS is just not doing anything. But yeah, you guys, as always, are free to email me if you have anything that you want to ask, or come to my drop-in hours. But
Thank
yeah,
you.
if I don't see you guys, I hope you guys have a great holiday. And I will see you guys Monday, I guess.